Hello everybody, welcome to Deploy 2020. My name is Chris Higgins and I am the Vice President of Infrastructure at DigitalOcean. I want to spend a couple of minutes talking about the benefits of building simple infrastructure. As with so many things in technology, the range of available solutions can be overwhelming. The payback from focusing on simplicity in your infrastructure is the ability to make significant changes with minimal risk. In thinking about simple solutions, I want to differentiate between complex and complicated solutions. Complex solutions are great, it's the complicated solutions we want to avoid. Think about Lego bricks for a moment. The complex materials engineering science that goes into creating Lego bricks is hidden by the consistent, predictable simplicity of how they interconnect. A quick search on YouTube for complex Lego builds returns examples of engines, gearboxes, Rubik's Cube solvers. And there are builders everywhere creating their own Lego masterpieces. And the only knowledge they need to start is how to connect two pieces together. Once you know how to connect those two pieces, any of those builds is within your skill set. Contrast that with a 3D printed solution. The end result might use less material, but once printed, it's going to be a lot harder to make small changes. And a good 3D printing solution requires you know a lot about the materials you're using and how they respond to the environment. Think about infrastructure the same way, and you can easily create complex business solutions that scale well. There were a number of tests to understand if an infrastructure is simple enough. Is it understandable? Could you explain it to your grandmother? Is it observable? Do you know what has happened and what is happening? Is it scalable? And remember, when we think about scalable, it's not just scaling up, it's also being able to scale down. Is it secure? Do you know what data is there? Do you know how the data is protected? And if you don't, who does? Is it predictable? Do you have the right key performance indicators to make decisions about what needs to happen in the infrastructure? And is it repeatable? How much is lovingly handcrafted and how much is automated? Let's take those in sequence. Firstly, understandable. Have a standard design pattern that you use for services. Common example, microservices, where specific functions operate as a separate discrete service. Think of authentication, logging, databases, static file servicing as separate services. In planning the layout of those services, align them to the underlying infrastructure fault boundaries. If the infrastructure you're using has got multiple separate facilities, put your primary in one, put your secondary in the other. If you've got fault domains within your environment, make sure you're spreading your services across those boundaries. Make bold, simplifying decisions. For example, why have both HTTP and HTTPS? Why not just turn off HTTP if all it's doing is redirecting to HTTPS? Plan for sufficient capacity during normal operations and expected failures. Number 2, is it observable? Be aggressive with monitoring. Monitor everything. Use percentiles to understand what is happening. Don't use averages. Averages will not help you. Be conservative with alarms. Only things that require action from a human should generate an alarm. If it's not going to require immediate action, then it should not generate an alarm. You should spot that issue in your metrics. You should not rely on an alarm. You want the alarms to be actionable so that every time an alarm fires, somebody will take immediate action. Use a combination of good metrics and valid alarms to understand how to make things better. Feed them back into the work effort to say, this alarm occurred, this metric is saying we need to do work, these are the plan we will follow to get it better. Third on the list, scalable. Scalable is an interesting one. I already mentioned you need to be able to scale down as well as scale up. One of the things that really helps with things being scalable is if you're comfortable making changes a lot. And the easy way to get comfortable making changes a lot is exercise the infrastructure frequently. Things that are supposed to be capable of failing over, fail them over. Things that are supposed to be easy to deploy, make them easy to deploy. Make rollbacks automatic. In the middle of a deployment, if the deployment sees something going wrong, it should automatically trigger a rollback. It should be perfectly safe and normal. Rate limit your deployments. You don't want a deployment that is going to go run across the entire infrastructure and take everything down, start to deploy, and then bring everything back up again. Rate limit the deployments. Get to the point where you can swap out a machine for another machine easily and safely. If you're at that point, You can add capacity or remove capacity. If you've got small machines, you can replace them with big machines. If you've got big machines, you can replace them with small machines. But you can do it in a seamless way. Exercise your infrastructure all the time so that that scaling action is low risk. Fourth on the list, security. Security is one of those things that's hard to retrofit. It's hard to come back afterwards to an infrastructure and add security where it's not there at the beginning. So it's worth spending the time at the start thinking about the data, thinking about the data you need to protect, protect it when it's in flight, protect it when it's being stored. Use a secrets management system for secrets. Don't try and invent your own solutions for storing passwords. Use one of the existing secret management systems that's out there. Don't invent your own crypto. Use standard crypto. Use TLS everywhere. Understand your security priorities. Before you get to your first security incident, understand the priorities. If it is better to have a security triggered outage than lose data, then be comfortable in the event of a security issue shutting things down until you've got the data in control. You can recover from an outage. You can't unleak data. Make your infrastructure predictable. Understand the impact of failures. Decide how services will fail. Will they attempt to degrade gracefully, or will they just fail cleanly? You don't want a client that is trying aggressive retries pointed at a service that is under pressure, because the service that's under pressure is just going to go and fail to respond. The client's going to retry harder, and now you're making things worse. So align the failure behaviors across all of the services. Make your infrastructure repeatable. You shouldn't treat your servers as multifunction devices. If we have laptops and tablets, we install lots of software, we install lots of applications, we context switch between applications. That's okay for laptops and tablets. That's not okay for servers. You should treat your servers as close to possible a single function device. They should have everything that they need installed and nothing else. Don't end up with a server that is the place where you install all of the random tools, because that adds to the complexity. It's hard to be able to imagine what happens when that individual server fails. So treat servers as single function devices. If you think of your infrastructure that way, then you end up with a collection of easy to scale components that work together, that fail gracefully, that scale to deliver your entire solution. That solution has a benefit outside of just the infrastructure. It helps when it comes to how you find the right people to operate in the environment. With an infrastructure that you compose from discrete services and components, you can hire junior people who will be able to operate safely in the environment. Your senior people can be working on the hard problems instead of spending their time training the junior person how to navigate a complicated infrastructure. It also makes it easier as you plan for future growth, as you look at how teams should be responsible for their services and how the services grow. With each component delivering a specific part of the solution, it becomes very easy to build teams and grow teams around those functions. When a team owns something very clear, then goal setting, career development also naturally drop out of that model. We're running out of time, so let me talk about some of the common pitfalls. Do backups. Replication is not a backup strategy. If you delete or destroy or corrupt the data in part of the replication job is to spread that deletion or corruption to all of the copies. So do backups. Replication is not a backup strategy. If you don't exercise your failover or redundancy in your designs, they won't work when you need them. So exercise failover and redundancy. For your most important production service, don't chase the latest technology. Use things that you know are safe and true. Try hard not to test in production. That's a tough one. Nobody's got lots of spare capacity lying around, but try hard. It goes without saying, rebooting is not a long-term fix. If you have to reboot something to get it back working again, you need to spend some time digging in to understand what's going on behind the scenes. I'll leave you with 4 takeaways from this session. Find a design pattern that fits your needs. Use it often enough you know where the sharp edges are. Security is easier if you build it in from the start. If you have to do it twice, automate it. And then building simple solutions is neither quick nor easy, but the benefits do pay back quickly. Every action you take in that environment should make things more simple, not less. Thanks for listening and enjoy the rest of the conference.